So this is formal charge. It is different from oxidation state or an actual charge of an ion. So keep that in mind, but this is something that we use to determine if a Lewis structure is a good Lewis structure or a bad Lewis structure, or if we can draw a better Lewis structure. You want to have formal charges close to zero. Formal charges of zero for every atom in a molecule, in some molecule, is going to tell you that the Lewis structure that you've drawn is a good Lewis structure. So treat covalent bonds as if the electrons are shared equally. Okay, so when you are doing formal charge, this is what you do, right? Even though they're not. So to find formal charge, you can find some formulas in textbooks. I tend to like to just look at it and think about it instead of worrying about some formula. So you start with the number of valence electrons that an element has, and you subtract the electrons that an atom in a Lewis structure has, and then you get the formal charge. So if we look at carbon dioxide, I'm going to draw a circle around the electrons that count for oxygen. Right? Now those lines represent 2 electrons. So if I draw a circle here and go right through, I've now satisfied, remember, for formal charge, we treat those bonds as if the electrons are shared equally. So 1 electron is going to count for oxygen and 1 counts for carbon. Okay, so whatever's in the circle counts for oxygen. Well, oxygen normally has 6 electrons. Normally, or like when it starts off, an atom of oxygen has that. Well, inside that circle, I see 2, 4, 5, 6, minus 6. Right? So we get a formal charge at CF, whatever. So formal charge is 0. That's good. So now we look at the carbon. The other oxygen is going to be the same as this oxygen, but we look at the carbon. We could take a circle around its bonds, and we see that we have 1, 2, 3, 4 electrons in that circle, and carbon starts off with 4 electrons, minus 4 again, 0. So carbon dioxide, is it a stable thing? Yeah. We're trying to figure out how to get this stuff out of the atmosphere, right? If we could, we expect that our Earth isn't going to warm as quickly, right? Our climate's not going to change as much. So carbon dioxide is a stable molecule. That's the point I'm trying to make, is that we have formal charges of 0, and it's a stable molecule. Right? Reactive things, you often see that the formal charges are not all 0. Although this isn't always true. But let's look at ammonium. So this is an ion. We see the parentheses and the positive charge. If we look at hydrogen, right? Hydrogen, you draw a circle. Hydrogen starts off with 1 electron. I see 1 electron, formal charge is 0. So for hydrogen, as long as it's bonded, it has a formal charge of 0. You don't need to worry about it a whole lot. The nitrogen has 4 bonds, so 1 electron from each bond. Nitrogen starts off with 5 electrons, so it's N, 5 electrons, but it only has 4.
Miss Amon, please come to the front desk right away. Your parents are waiting for you.
You can not worry about the electrons there. So we have 5 minus 4. This is plus 1, right? The FC, the formal charge, or CF, is plus 1 for that. And this is going to make sense. Something about formal charges. They have got to add up to the total charge on the species that you're looking at. In this case, we're looking at carbon dioxide, which doesn't have a charge. So all of the formal charges need to add up to 0. And they do, they're all 0. For ammonium, the formal charges, however you do it, have got to add up to plus 1. Hydrogens are all 0, nitrogen's plus 1.
Odd best, but please come from front desk. Last call.
We look at 3 more. Thiocyanate ion. So we've got sulfur, carbon, and nitrogen. Sulfur normally has 6 electrons. And here it has 7. formal charge is -1. You can now that that's -1, these two have to add up to 0 because we've got our -1 already. But we have to take a look. In carbon, we do this. Carbon starts off with 4 electrons. This is sulfur, carbon. Carbon is 0. Nitrogen has to be 0 now, but we can check. So nitrogen, we've got 2, 3, 4, 5. We've got 5 electrons. Nitrogen usually has 5 minus 5 is 0. Right, so those are the formal charges for the first ion. I'm going to get rid of these. We'll look at some more. Sulfur, once again, sulfur has 7. Goes -1. Nitrogen. Right, there's 1, 2, 3, 4 electrons. That's +1. And carbon. Carbon has 5. Okay, so you notice we've got the first polyatomic ion, we've got -1, 0, 0, they add up to -1. The second one, we've got the same number, same atoms, same charge, -1 plus 1, -1, they still add up to -1. Last one. Sulfur. So 6 is 0. Carbon minus 4 is 0. Nitrogen, 1, 2, 3, 4, 5, 6. We got 0, 0, -1. Okay, so if we look at these formal charge analyses of the 3 different polyatomic ions, we would look at this and we say, okay, the top one and the bottom one are better than the middle because we have more atoms that have a formal charge of 0. Okay, so these make more sense. Then your question will be, well, which of those is better? Is it better to put the -1 charge on sulfur, or is it better to put the -1 charge on nitrogen? And I would say it's better for nitrogen because nitrogen's more electronegative. Maybe some arguments could be made that sulfur is a little bigger; it allows it to spread out. So that might make some sense. But I like this Lewis structure the best because nitrogen's the most electronegative. So that means extra electrons are going to feel its nucleus a little bit more, and they're going to go there.